Hello guys, this is the TI-84 guy. I'm back with another video. This has definitely been my most productive day as far as creating videos. So I have at least one more, possibly two more videos that I wanted to do. So let me just kind of jump in and start with this one. This question was taken from the March 2020 SAT, and one of the things that I want to do is, this is one of the few quadratics that I've actually tried to solve. As I looked over the exam, at least in the calculator section, there weren't as many quadratic problems as there normally are, so there weren't as many opportunities to use the programs that I've created. But there are definitely a few, so I wanted to show this. So what I'm going to do is I'm going to show you how you can solve this using my program, and I also want to show you how you can solve this using your calculator, just using your calculator the regular way that you would use it. All right, so what we have here, we have a quadratic function. It says the function h is defined as shown. For what value of x does the function h of x reach its minimum? So we're trying to find where does this parabola reach its minimum. Now, what I'm going to do is I'm going to use a program that I've written specifically for these kinds of questions. So this is in factored form. And basically what I'm going to do is I'm going to take this quadratic and I'm going to put it in the vertex form. And when I put it in the vertex form, that's going to tell me what the minimum is, because the vertex is the minimum. All right, so what I'm going to do is I'm going to go to my program. And it's called Quadratic. So here we have it. So from here, you're going to go to the program. And then we're going to go down to here, number 9, Quadrate. That's what I call it. And press enter again, and you've got 4 options here: standard, vertex, factor, or 3 points. So this gives you the input format of the quadratic that you're dealing with. The quadratic that we were dealing with was factored, so I'm going to choose 3, and the a term is 1. The f term is also 1. The o term is a -5. The I term is also 1, and then the L term is a +5. So I just choose 5, and then I press enter. Now it says, what output format do you want? And I want to put it into the vertex form, because that's going to tell me where the vertex is. So this is telling me that the vertex is at 0, -25. So the vertex is at 0, a -25, so it's on the y-axis. So, so the answer for this one would be, let's go back to the test. So the answer for this would be 0. That's it. That's where the vertex is. So that's it. Basically, this problem is pretty straightforward. It's not that complicated. They're just asking you to find the vertex. But now I'm going to show you how to find this if you don't have the program Quadrate. So here, all you're going to do is you're going to take the function, the quadratic function that they gave you, and you're going to enter it. Let's see, x -5, parentheses, and then x + 5. Okay? So you know that's actually the difference of 2 squares, but here's what we're going to do is now we're going to graph this. Boom. And I'm going to change the window so that we can actually see where this guy, the minimum is. So I'm going to make this, the y minimum, I'm going to make it a -40, just so we can see exactly what's going on. I'm going to graph it. Uh-oh. I made a mistake here. Let me go back and fix that window. Yeah, that was supposed to be a -40, not 40. So a -40. So we're going to graph it. And you can see that the minimum occurs right here. And you can also see that it's on the y-axis. Now, to be precise, you can use second trace, and we're going to use 3 for the minimum. So that's going to help us find the coordinates of the minimum. So all you have to do is the left of where you think the minimum is. So go a little bit left, press enter. And then I'm going to go a little bit to the right of where I think the minimum is. I'm going to press enter again. And then for the last time it says guess, I'm going to press enter again. And there we have it. So now if you look at this, it has a negative 1.279 e to the negative 6. Now, that is a really, really, really small number. The calculator is trying to get to 0, but it's having a little trouble doing that. So this is as close as it can get. But what you guys should understand about your calculator is that when you get a number like this, it's basically saying, hey, I'm trying to get to 0, but I didn't quite get here or get there, but this is as close as I could get, and it's a really, really small number. So for all intents and purposes, it's 0. So, and the calculators do this. This function does this a lot. It won't give you sometimes it won't give you the precise number for the minimum, the x value. The y value it never has a problem finding. It's usually the x value that it has issues with. So, but you should know that this is actually 0. So the x coordinate would be 0. The y coordinate is a negative 25. That's what we saw on my program. Now, that's one of the things about the program is that it gives you specifically where the vertex is. So this is doing kind of an approximation. The program is more precise. So that's another plug for the Quadrate program. So, so if you'd like to get a copy of the program, all you have to do is send me your email address, make sure it's spelled correctly, like this video, subscribe to my channel, and I will get you this program as quickly as possible. Now, this program will only work on the TI-84CE, the Quadrate. I do have a version for the TI-84 Plus. It's called the Quadratic. They're essentially the same program, except that the Quadrate has a little bit more functionality. It's a little bit more flexible. It can handle fractions and decimal inputs, but that's the only difference. So if you'd like to get this program or the version for the TI-84 Plus, just send me your email. And like I said, like the video, subscribe, and I'll get it to you as quickly as possible. All right. Thank you guys, and have a good evening. Stop.